Okay, we're going to look at synthetic division. Now, synthetic division has a lot of different uses for it, but first let's learn what the process is. So you can use it to divide. Now, you would know the answer here. If you had x plus 3 and you multiplied it by x minus 2, you'd have x squared minus 2x plus 3x, which is plus x, minus 6. So since that's what we have as our answer, we know the answer to this must be x minus 2. So, but this is how it works. So in the little box, you put the 0 of this. Now, we've talked about this many times. The 0 would be when this is 0, and that would be negative 3. The 0 is negative 3. Or you can think in terms of your translation of graphs, that's to the left 3, so it's negative 3. You put negative 3 in the little box. You put your coefficients here. And you leave a space here. So this 1 gets carried down. And then it's continually multiply, add, multiply, add, multiply, add. So 1 times negative 3 is negative 3. I add those together. Negative 3 times negative 2 is 6. I add those together. And then my answer is right here. But since this started as quadratic, and I divided out an x, I'm now down to x to the first minus 2 with a remainder of 0. If we were doing this one, you might notice, again, negative 3 in the little box, this is missing the squared term. It is no x squared term. So I can't just ignore that. I have to put a 0 in for it. So I'd have 1, 0, 1, negative 6. And then the process is the same. You multiply, you add. You multiply, you add. You multiply, you add. Sometimes I put that to separate that off. And so again, what I have here has to be 1 degree less than I started with. So my answer would be 1x to the second minus 3x plus 10 with the remainder of negative 36. Or some people write the answer as negative 36 over x plus 3. So you can use it to divide. You can use synthetic division to find function values. Now, if we put negative 3 in here by hand, that would be negative 3 to the third plus 3 times negative 3 squared minus negative 3 minus 2. Now, I try this lots of times in class. It's very easy to make a careless mistake on this. Let's see if I do. Let's see, that would be negative 27. Then this is 9 times 3 is positive 27 plus 3 minus 2, and so I get 1. But a safer and a quicker way to do it is with synthetic division. So I'm going to put my 1 here, my 3, my negative 1, my negative 2. None of the terms are missing. 3, 2, 1, no variable at all. You're constant. In the box, I'm going to put exactly the number I was given. Only use the opposite in the little box if it is given as a factor, x minus 3 or x plus 2. So I'm going to put negative 3 in the little box here. Again, you continually multiply and add. Multiply and add. Multiply and add. And there's the answer. The answer was 1. So again, it's quicker this way and safer because you had all those negatives. So on this one here, we've got, in the little box would be exactly the number I was given. 1, oh, the cubic term is missing, so I need a 0. Negative 3, 1, negative 2. Carry that down and continually multiply and add. Multiply and add. Multiply and add. Multiply and add. So this must equal negative 5. So that's another use you can find function values. It's called the remainder theorem. Another one is to check if you have a root or a factor. So all of these mean the same thing. Is x minus 3 a factor of that? Is positive 3 a root of the equation? Is positive 3 a 0 of the function if we were to graph it? So in all of that, we use synthetic division. Now here it is as a factor, so that's when I take the opposite. But if it's given to me as a number, I do that exact number. Let's see, is anything missing? Cubic, quadratic, linear, constant? No. So I'd have 1, negative 7, 15, and negative 9. multiply and add, multiply and add, multiply and add. So the answer here is yes. Because the remainder is 0. That's how you know when something goes in evenly. 2 goes evenly into 12 because there's no remainder when you divide. And so, is it a factor of that? Yes. Is it a root of the equation? Yes. Is it a 0 of the function? Yes, all because the remainder is 0. So, same process, same way to interpret the answer, but 3 different ways the question can be worded. And then finally, you can use it to solve higher degree equations. Now, you know that sometimes when we have 3 terms, we can group them 2 and 2. But notice here, you take out x squared and you have x minus 7, and you're not going to get that over here, so that doesn't work. You can try your rational roots theorem and test out your numbers, or what we generally do is find one root on the calculator. So I did one on the calculator. I know one of them is 3, because it crossed the x-axis there. So I'm going to put a 3 in the little box. 1, negative 7, 15, and negative 9. No terms are missing. Bring down the 1. Multiply and add. Multiply and add. Multiply and add. So we know, so number 1, this must come out to be 0. If it doesn't come out to be 0, you either did something wrong here, or 3 wasn't really a root. So if you don't get 0, don't go on. Something's wrong. Go back and figure out why. So then what is this answer? It started as cubic, so now we're down to quadratic. And then this you can factor. That would be x minus 3 and x minus 1. Would give you x squared minus 1x minus 3x is minus 4x plus 3. So x would equal positive 3 and positive 1. And it already equaled positive 3. So that means we have 1 and 3 is what we call a double root there. Or the question could ask you to completely factor. If you know you have a root at 1, you'd have x minus 1, x minus 3, and another x minus 3. Or you could write it as x minus 1 and x minus 3 squared. So you can use synthetic division. If you know one root, you can get down to this one's called the depressed equation because it's 1 degree less than the original. It's pushed down 1 degree. So then you factor that. Sometimes it doesn't factor, but you could always use quadratic formula. You can use it to check if you have a root or a 0 by checking if that remainder is 0. You can find a function value without going out the long way. Again, always be checking and see if you have any missing terms. If this is 4, there has to be 5 terms. The quartic, the cubic, the quadratic, the linear, and the constant. There's always one more than this because of that constant. Or you can just flat out divide. So that's synthetic division.